Hello everyone.
Welcome to Gen Z Scholars. My name is Kiam.
And my name is Amy.
And today, we will be going over the first lesson of Unit 1.
Unit 1 covers a lot of the basics and mainly focuses on 4 things: the atom, the element, the electron, and the periodic table.
First, you will learn how to measure an element via moles and molar mass.
Moles are a way of measuring the quantities of very, very, very small substances, like an element or compound.
For example, 1 mole of sand grains would be enough to cover the whole Earth with 3 inches of sand. That is a thick number.
On the other hand, 1 mole of iron grains wouldn't even be enough to fill your dog's food plate.
In the context of chemistry, we use the mole as a convenient measure when weighing substances, as atoms are extremely small.
1 mole is equal to 6.022 times 10 to the 23 particles. This is known as Avogadro's number, and it is given to you on your reference sheet.
This means that 1 mole of helium gas will contain 6.022 times 10 to the 23rd helium particles. 2 moles of helium gas will contain 1.204 times 10 to the 24th helium particles, and so forth.
But the kid is not my son. Woo! She says
Molar mass defines the grams per 1 mole of a substance. Each substance has a fixed molar mass, and the molar masses of each element are given on the periodic table.
Molar mass and moles are measurements that are completely different, but easy to mix up. Just remember to use this formula. The number of moles of a substance is equal to the mass of a substance divided by its molar mass.
This formula will also be given to you on the reference sheet, but you're gonna have to use it so many times that you end up memorizing it.
Actually, let's use it right now with a practice problem. We will walk you through this one, but at the end of the video, you're going to do it by yourself.
Okay, so let's start off with finding the molar mass of a substance. Let's say you have 36 grams of water and you're trying to figure out how many moles you have.
First step here is to look at the formula. We need to find moles, so our calculations need to involve the mass and molar mass of water. We have the mass, and we have the ability to calculate the molar mass.
To calculate the molar mass of a substance, you need its chemical formula first. Water is pretty simple, H2O, so 2 hydrogens and 1 oxygen. Look at your reference sheet and you'll see that the molar mass of hydrogen is 1.008 grams per mole. The molar mass of oxygen is 16 grams per mole.
Since we have 2 hydrogens, we multiply the molar mass by 2, getting us 2.016 grams. Since we have 1 oxygen, we multiply the molar mass by 1.
Now we add 16 with 2.016 to get the overall molar mass of water.
Well, according to my calculations, if I'm not mistaken, that should give us 18.016 grams per mole.
Okay, that's enough now. Anyway, back to the original formula. Now that we have our mass and molar mass, just plug in the numbers. So it's 36 grams divided by 18.016 grams per mole.
The calculator says we get 1.9982238 blah 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 whatever. On an actual AP exam, or on your teacher's exams, use that answer.
For us, however, we say we have roughly 2 moles of water. Sorry, we aren't very fancy, but we got the job done. Anyway, back to the lesson.
There are 2 conditions that are commonly used in chemistry and generally in science. STP, which stands for standard temperature and pressure, and standard conditions. Believe it or not, these are 2 different things. But first, let's talk about the units of measurement for these conditions.
First things first, the conditions refer to pressure and temperature. Pressure is often measured in atmospheres, abbreviated as ATM. However, in rare cases, the AP exam might throw in millimeters of mercury, abbreviated as mmHg, or torr. Not to worry, the conversions are given on the reference table.
As for the temperature, the unit will always be either Celsius or Kelvin. If any science teacher hears the word Fahrenheit, they will implode.
Also, fun fact about Kelvin, 0 Kelvin represents absolute zero, or the lowest possible temperature. Fahrenheit and Celsius can get into negative numbers to represent temperature, but 0 Kelvin is the coldest it gets. No motion, no heat.
But back to the two common conditions, STP and standard conditions.
Okay, you've officially lost me. How are these different things? And more importantly, how am I supposed to remember?
Well, STP is actually given to you on the reference table and will more often than not be used solely for gases. At STP, temperature is 273 degrees Kelvin or 0 degrees Celsius, and pressure is 1 atmosphere.
Oh, that's not that bad. So if I'm remembering this correctly, standard conditions are room temperature, 298 Kelvin or 25 degrees Celsius. Oh, and also 1 atmosphere, right?
Exactly. And one more thing about STP. 1 mole of any gas at these conditions will always have a volume of 22.4 liters. This information is also in your reference table.
Damn, what does this reference table not have?
So much. But for now, let's move on.
Now let's see if you have been paying attention. Question 1. How many moles of carbon dioxide, CO2, are contained in 176 grams of carbon dioxide? Question 2a. Find the molar mass of aluminum sulfate, Al2SO4 And question 2b. How many grams are present in 250 grams of aluminum sulfate? And finally, question 3. How many molecules are in 2.24 liters of neon at STP? Now you can pause the video and try to answer these questions on your own. The answers and explanations will be given to you by my good friend Kiam in just a moment.
In our problem, we are given 176 grams of CO2, or carbon dioxide. According to our periodic table of elements, carbon weighs 12 grams per mole, whereas oxygen weighs 16 grams per mole. Since there are 2 moles of oxygen in carbon dioxide, we multiply our molar mass by 2. When we add this all together, it's 12 grams per mole plus 2 times 16 grams per mole, giving us a grand total of 44 grams per mole. That's the molar mass of carbon dioxide. Now, remember we were originally given 176 grams of carbon dioxide, and we want to find the moles. So then, we take our 176 grams and multiply it by the molar mass. For every mole, there are 44 grams. Grams cancel out, and then we're left with 4 moles of carbon dioxide, or CO2. In our problem, we are trying to find the molar mass of aluminum sulfate, or Al2SO4. Since there are 2 moles of aluminum, we multiply 2 by the molar mass of aluminum, which is 26.98 grams per mole. We have 3 moles of sulfur, so we multiply 3 times the molar mass of sulfur, which is 32.07 grams per mole. We have a combined total of 12 moles of oxygen, since 4 times 3 is 12. So 12 times the molar mass of oxygen, which is 12 grams per mole, is our combined molar mass for oxygen. Adding all of these molar masses together will give us our combined molar mass for aluminum sulfate, or Al2SO4, giving us a grand total of 342.17 grams per mole. In our next problem, we are trying to find how many moles are in 250 grams of aluminum sulfate, or Al2SO4. Using our molar mass from the previous problem, we can multiply our grams, 250 grams, by the molar mass, which is 342.17 grams per mole. grams cancel out, leaving us with our moles. In this case, it's 0.731 moles of aluminum sulfate and 250 grams of aluminum sulfate. From our lesson today, we know that 1 mole of gas at STP has a volume of 22.4 liters. Given 2.2 liters of neon, we multiply its volume by 1 mole of neon over 22.4 liters, giving us 0.1 moles of neon.